Aging is the buildup of air. That's all aging is. The buildup of air. Air in our DNA, air is in protein synthesis, air is at the atomic and molecular level, and that's where quantum computers comes into picture. Because quantum computers live in the quantum world. Immortality is, therefore, possible. The quantum computers will be able to isolate the process which makes aging possible.
According to physicist Michio Kaku, there is no fundamental law of physics that dictates we must die. In fact, he suggests that both biological and quantum immortality might be within the realm of possibility. These ideas challenge everything we think we know about life and death, raising profound questions about the nature of our existence and what the future may hold. Biological immortality could be achieved by reversing the aging process at the cellular level. Scientists now understand that aging is not an inevitability but rather a consequence of molecular damage that accumulates over time. DNA errors, protein misfolding, and mitochondrial dysfunction all contribute to the gradual breakdown of our bodies. But what if we could repair this damage as fast as it occurs? If we can unlock the secrets of cellular regeneration, we might be able to extend life indefinitely, or even eliminate aging entirely. Some organisms, like the hydra, a tiny freshwater creature, demonstrate a form of biological immortality, as their cells do not degrade in the same way ours do. Their continuous regenerative capabilities allow them to avoid aging entirely. Other creatures, such as certain species of jellyfish, have the ability to revert their cells back to a more youthful state. If we could harness these mechanisms, the implications would be revolutionary. Scientists are actively researching ways to achieve this, from genetic engineering and stem cell therapies to advanced nanotechnology that could repair cells from within, essentially turning back the biological clock. But while biological immortality is based on tangible biological processes, quantum immortality delves into the bizarre and counterintuitive world of quantum mechanics. According to the many worlds interpretation of quantum mechanics, reality does not follow a single, linear path. Instead, every possible outcome of a quantum event plays out in a parallel universe. This means that every time you face a life-threatening event, there could be a universe in which you die and another where you survive. From your own perspective, you would always continue to exist in one of these realities, meaning that, in a very strange way, you might never experience death at all. This concept is known as quantum immortality, and it forces us to rethink what it means to die. If every time you die in one universe, your consciousness continues in another, does that mean you are functionally immortal? And if this is true, why don't we remember previous deaths? One possible explanation is that memory is confined to individual universes, meaning that while your consciousness continues, it does not carry over past experiences from other timelines. Another possibility is that we only exist in realities where we do not recall our previous deaths, our survival is seamless, and any past versions of ourselves that perished simply cease to exist in our perspective. To better understand this idea, physicists have proposed thought experiments like quantum suicide. Imagine a scientist linked to a quantum particle in superposition. If the particle collapses one way, they survive, if it collapses another way, they die. Each measurement splits the universe into multiple outcomes, meaning that in some branches, the scientist dies, while in others, they live. From their own perspective, they would only ever experience the realities in which they survive, reinforcing the illusion of immortality. However, this experiment also highlights a paradox. While the scientist might feel immortal, they have no way to prove it, as observers in other branches would see them perish. One of the biggest challenges to quantum immortality is whether consciousness itself operates according to quantum principles. The human brain is a warm, wet environment that typically disrupts delicate quantum states, making it unclear if quantum mechanics applies to our thoughts and experiences. Some researchers speculate that quantum effects play a role in cognition, but there is no definitive proof. If consciousness is purely a classical phenomenon, then quantum immortality might be nothing more than an interesting idea with no basis in reality. However, the rise of quantum computing could bring us closer to understanding these mysteries. Unlike traditional computers, which process information linearly, quantum computers operate on probabilities and can simulate complex biological and atomic interactions with unprecedented accuracy. By using quantum computing to model molecular processes, scientists could potentially decode the exact mechanisms of aging and find ways to halt or even reverse it. This means that even if quantum immortality remains a theoretical construct, biological immortality could become a reality within our lifetimes. The ability to manipulate DNA, proteins, and cells with pinpoint accuracy would give us control over life itself. If quantum immortality were real, it would upend our understanding of existence itself. Death, as we perceive it, may simply be an illusion, a transition from one reality to another, rather than an absolute end. If this is true, then does that mean we are destined to exist forever, continuously shifting into realities where we survive? Or are there limits to how far our consciousness can extend? Could we, at some point, reach a reality where survival is impossible? These are questions that remain unanswered. While this concept remains unproven, it forces us to question the very nature of reality and consciousness. Are we truly bound by a single fate, or do infinite versions of ourselves continue living in alternate timelines, oblivious to the deaths we have supposedly experienced? If we do exist across multiple realities, what does that say about free will, fate, and the fundamental structure of the universe? As our understanding of quantum mechanics deepens and our technology advances, we may one day uncover answers to these profound questions. Whether through biological breakthroughs that eliminate aging or through deeper insights into the quantum fabric of reality, the future may hold possibilities we can scarcely imagine today. Perhaps, one day, death itself will become an outdated concept, replaced by an endless existence across infinite realities. Until then, the quest for immortality, whether biological or quantum, remains one of the most fascinating frontiers of science, a journey into the unknown that could redefine what it means to be alive. If you're intrigued by these mind-bending concepts and want to explore more of the universe's greatest mysteries, be sure to check out our sub-channel for in-depth discussions on quantum mechanics, futuristic technology, and the nature of existence.